All right, I think it's a minute over the hour, so we can start. Welcome everybody to the session on Oracle Real Application Clusters. I guess we have one person here so far, and I guess more will join as we continue. So this is a new thing that is started by Stephen Feurenstein, and it is actually very interesting, very interactive way for customers to actually reach out to product development folks. So for example, you can reach out to us so we can know what you're using, what feature that is very interesting to you, so we can focus more on those. And it's actually very good for us to know what the customer issues are and what they're using. Now, there are many ways to reach me. I am, by the way, Anil Nair. I'm the Oracle Real Application Clusters Product Manager. And I'll just share how the ways that you can reach me. For example, here you have, there you go. There you go, okay.
Not sharing yet.
Not sharing yet, yes. I'm getting there, there you go. And share screen, there you go. Sorry, it's taking me a while to get all this going. There are multiple screens here. So I'm Anil Nair, like I said, and this is the first office hour. And there are the ways that you can reach out to me. We have a Twitter account, RAC Master PM, myself, and Oracle RAC PM for Marcus. You can reach either of us, and that's my LinkedIn in case you have any questions. And we have a lot of this 8i, 9i, 10G, OPS to RAC slides in my slide share. So this is going to be a very interactive session. So I'm not going to spend much time going through a feature set unless there is a need, to go through a presentation deck. This is supposed to be more interactive. So please, feel free to ask any question, and I'm going to keep checking the chat. In fact, unfortunately, one of my colleagues is called in sick. Otherwise, we would have two people doing it. So far, I see no question yet. But like I said, everybody's muted. So, the best way to ask question is through the chat window. So please feel free to ask your question, whatever it is, regarding Oracle Real Application Clusters here. So while I wait for that, I want to just also highlight one more thing. I'm not going to be speaking much about any future releases or anything, but just in case I talk about a feature that may or may not make it into the release, I just want to make sure you acknowledge the safe harbor statement.
Okay. Good morning, Anil. Can you hear me?
Yes, I can hear you.
Hi, my name is Samiksha, and I do have a question about read-only loads on RAC in 12c release 2. But give me like 5 or 7 minutes. I'm driving into work, so once I'm logged in, I'll be able to see everything with my glasses on. But I just thought I'll log in and at least listen in while I'm driving. So as soon as I'm logged in, I'll actually put the question in the conversation tab and go from there.
Perfect. No problem.
Thank you.
Sure. And this is recorded, so you can always look at it. So I'm going to just jump into that specific, slide deck. Actually, I have a slide deck on this. So Samiksha's question is now.
Anil, sorry to disturb. Your audio just went very quiet. I can barely hear you.
Is this better now? Wow.
Yeah, that's better.
Okay. I just came closer to the microphone. All right, great. So the question that Samiksha asked, just to repeat myself, is about Oracle, read-only nodes. That is a new feature in Oracle 12c. And if you give me a minute, I'm just going to fast forward to that deck, which talks about this. So this way you can actually see what I'm talking about. And I have some other cool stuff to show you too, but I'll just wait for that. A little bit. As the questions come in. So the one feature that I'm going to talk about, and sorry, I'm just going through this very quickly. Might as well actually go through the deck directly. There you go. Give me a second while I get there. So what is this read-only home or nodes, by the way? So read-only nodes is a feature that we introduced a bit recently, okay? So what does that mean? There you go. Okay, there you go. And okay, I hope you can see the screen, the screenshot. So essentially, a read-only home is a read-only node. Sorry, just to keep saying the wrong term.
We just lost the screenshot.
What's that? Sorry.
It's showing a banner saying Windows 7 DVI.
Ah, it again took away the screenshot. Okay, let me just get one more second to that, and I'll just start showing. Okay, there you go, and there you go. Okay, now we are good. So before we just jump into what is this read-only nodes, so there are a couple of reasons why this, first of all, let me give you a history of why this read-only nodes were introduced. So in 12c release 1, we introduced this distinction between a node. What does that mean? A node can be what we call as a hub node or a leaf node. So if you see here, these are actually hub nodes and these are leaf nodes. In 12c release 1, you're supposed to put your applications on this. And now in 12c release 2, you can actually have a read-only instance on leaf node. What does this mean? So if you see this 4-node cluster we have here, the nodes on the left, these sides, they are called reader nodes. And the nodes on the right, they are called the hub nodes. So if you have a system where you want to run your services on a certain subset of nodes, like in this case, node 3 and 4, I'm just going with 1, 2, 3, 4. You could create services for OLTP services that could be going on these nodes, right? On the left-hand side, you could delegate your read-only queries to be running in reader nodes. You might say, Anil, what's the big deal about it, right? Well, the big deal is this. You could run massive number of reader nodes. You could have 2, 4, 6, 8. The reason is, since read-only nodes do not have any kind of require or IO requirements in the sense of writes, so we don't do any kind of writes from the read-only nodes, which means what? That if a node is evicted or a node crashes, actually it's fine. We don't have to do any kind of recovery on that. We don't have to do any kind of IOs onto that part. So this is really, really cool feature because of which you can actually now utilize as many number of nodes as you want for your read-only. So if you look at this screen now, you could have what we call as a massive HTAP capabilities you could use. What is HTAP? HTAP is this new way to call systems which have converged OLTP and DSS. For example, HTAP itself stands for Hybrid Transactional Analytical Processing. So in this case, you see you have these two guys, which are your OLTP or hub nodes, and the pedal query coordinator is running here. And these are all your read nodes, and you read-only nodes or leaf nodes, what you call it. These guys can actually run all your parallel query here. And since RAC does not require all your nodes to be same capacity, these guys could be having massive amounts of memory, which means your parallel query can do a lot of, of their sorts and all those things that parallel queries do, and be able to funnel this information to the services that are requesting that. Now you can go a couple of steps further with this. With this, you could actually use in-memory database options. So when you use in-memory with RAC, obviously you get the best of both. In fact, in-memory with RAC on Exadata, you can even get like the best of the best. Because now in Exadata, you can actually cache these EHCC tables on flash cache in pure columnar format. So you can see that this is a really, really cool way by which you can, delegate a certain set of nodes as read-only nodes or leaf nodes, what we call it. What that gives you is the functionality to add as many nodes as you want. And as you know, in RAC, and regardless of whether it is the GI clusterware or real application cluster, the database side, you can add nodes without affecting any availability, right? So as you add nodes, you can delegate that to be read-only nodes. You start the instance. Obviously, when we do installation, we would choose the nodes which are read-only, and then we are all set. The instance is automatically started on them. The services that you define is started on them. So everything works out of the box. You do not have to do any kind of additional configuration on these things, and this survives readers. Okay. So hopefully that answers your question, Samiksha. That way,
I have a follow-up question on that. So in that case, ASM is shared across all read, write, and reader nodes, correct?
Right.
And does that tend to become kind of a bottleneck, or does it impact the performance of the read-write nodes by any chance? Because that's one of the concerns that I have been kind of wondering, is because you're adding more reads, and I know that reads really should not block anything that's happening with the read-write, but in general, would there be more traffic on the interconnect because of it, and would that impact the performance of the read-write nodes? Because that's the major concern, is your read-write nodes should not be impacted by what's happening on the read-only nodes, correct?
That's right, and that's a good question actually. I have talked about it earlier, and I will show you those slides. But let's talk. I think there were 3 questions in that. Let me address each of them.
Sure.
Having additional nodes or having additional read-only nodes, would that affect I/O or whatever? This is one of the reasons why I said these read-only nodes will have massive memory capabilities. You could do that. It's an optional thing. But regardless, even if they have some memory, they would have its own buffer cache, and the buffer cache is going to be managed by default by the Oracle typical buffer cache management. Which means once you guys pull in the data, let's say you start everything today, reads are going to be populated eventually, and there will be very less load per se in these choices. Now again, I know parallel query does direct reads, so might not be directly benefiting from this, but typical loads like any other DSS queries that you take, your ad hoc queries, your analytical queries, they can benefit from this. The summarization can benefit from it. The columnar formats can benefit from the cache. So in a way, having this scenario or having this setup or architecture actually may help you and reduce your IO requirements, because you're kind of segregating this. So remember, one of the big problems of having everything being done by read-write is the reads and writes on the same node could be causing could be affected by bottlenecks, mainly on the HBA on that node itself. Right now, with this new one, we are actually segregating it. We are separating it so that every component work to its optimal capability, right? So the node that is doing read, that HBA is very busy doing its kind of work that it's doing, and all across through the path, through the IO path, it's doing its work. The OLTP nodes are doing its work, so kind of having the best of both in this scenario. There are other couple of enhancements that we have done in Cache Fusion, which will actually help you in this case. Like, since you talked about interconnect, and since you talked about the overloading the interconnect. So I'm going to just for a moment, stop the screen sharing, and I'm going to show you what I mean by that. So there are a couple of features that we have introduced, and this is the feature that I'm talking about. Give me a second, and I will show it to you. So we have this feature called, there you go. Okay, I'm going to now. Okay. So before I just jump into what the feature is, let me explain, take a second and explain what is Cache Fusion. I'm sure everybody's familiar with Cache Fusion if you've been using RAC. But essentially, Cache Fusion, just for those new folks who might be joining us, Cache Fusion is by which we try to send data across the private network instead of relying on the slower rotating disks in the past, right? And the premise is very simple. We started with 8i and 9 and 10 and 11, and over the years we have improved cache fusion so much that until now, and when I say until now, because that's the feature that is coming up, until now, regardless of how many nodes you always have a minimum three-way communication. What does that mean? If you have 4 nodes, or 5 nodes, or 5 instances running on these nodes, at best, or the worst case scenario is you might have to send 3 messages. So in this case, this is the query, the guy who's doing the write. Suppose it is connected to node 1, which is the center one. That's a step 1, by the way. He might have to send a message to the master and get a response from the actual cache, which is in the fourth node. So this is how cache fusion worst case scenario is. We have over the years implemented DRM, which helps to optimize this to a two-way communication. Why? Because even though going across the network is faster, we realize that not going across the nodes at all is even faster than that. So we have optimized it to two-way. Now what we have done is now in 12C release 2, we have this feature by which we have actually figured out that, oh, you know what? It is not enough that we are just going over the interconnect. Sometimes other customers have really, really fast SSDs. And so we have this optimization where we say RAC will choose the most optimal path. So look at this animation. If you do a query, and if you think of a block that is in the memory of node 1, since the query is connected to node 2, this guy will go over the private network. Perfect. This is the best case scenario. Now, what happens if there is some kind of hiccup at the switch level or something? What would happen if there's any network congestion? Cache fusion automatically figures this out and says, you know what? I'm going to send this over the disk. So this way, we will always ensure that we will use all the components that are necessary to have a perfect, performance for you. Sorry, Judith just mentioned the sound is very weak. Is that better now? I'm not sure what's happening. Okay, I'm going to assume sound is good, but if it's not good,
it's a little better now.
Okay. Oh wow, it's going up and down, huh? Sorry about that, folks. We have I had a direct connection, but I think this new sharing thing, this office phone thing is not perhaps working. But do let me know if it is weak, and I'm very sorry about the sound quality again. But hopefully, so make sure that answers your question about all the points that you have brought up. Okay.
Yes, it does. Thanks.
Sure. And before I jump into the next aspect of it, there was another question about scan, and is there a best way to use scan, and what is the optimal number of nodes and all that? So for scan, it's been around for a while, and I was a bit surprised with that question. Nevertheless, it's a good question because this comes up all the time. How many nodes do we need for scan? Like how to set up scan in a 5-node cluster? Do we need it to resolve to 5 nodes? Let's explain scan a bit. Scan is what, this concept of scan was introduced because customers found it very hard to keep updating their TNS names.ora as nodes were added. So we said, okay, you know what? You define one entity, which is called the scan. And that scan you define in the DNS such that a scan entry would resolve into 3 host names of the RAC nodes. And this is regardless of the number of nodes you have. And we would take care of ensuring they're spread out across the nodes. And even for a 2-node cluster, we recommend that you have at least 3. You could get away with 2, but in case you add a 3rd node, you want to really have this 3 defined. And this is really the best thing in the sense that you do not want to add more as the number of nodes increase. So for a 2-node cluster, I would still say go with 3. For a 3-node cluster, obviously 3. For a 10-node cluster, same 3. And in the scenario that I showed earlier, where you have this massive amount of nodes, still 3. 3 is the number that we have tested and found out to be the most beneficial for having, it's kind of like a best in the sense that we will take care of spreading it out across the nodes. And at the same time, the customers connecting do not get impacted if a node on which the scan resolves to is down. So you kind of get the best of both worlds. Okay. Now, going back to the chat, I see there is another question. So let me just take that question. Good. Okay. So I see that the question is about, yes. So the question is about the future of RAC in the context of this new cloud and all those new things that are coming up. So the question is mainly, what is the future of RAC in the context of cloud and database cloud services? It's a very, very involved question that will take some time, because I hope we don't digress into other things. So the most, let's address the big question. RAC is only supported on Oracle Cloud in the context of cloud providers. There are technical challenges why it is not supported across other cloud providers. So let's not get into those things. We would always assume that it is best to do RAC, Oracle RAC on Oracle Cloud. In the context of the what is the future of RAC? So let me explain this via another way. Okay, so let me just sorry, there was a question in the chat which kind of caught my attention, so I wanted to make sure we talk about it. So let's explain a bit about RAC, and this is probably the best way to explain RAC and the cloud, so that you kind of get into the it is very clear that understanding. Okay, so this is actually a very good case. Now, what does RAC provide? I always talk about RAC in two separate contexts. One is about scalability and one is about availability. So what does that mean? So you can see when you start with a 2-node cluster, we have a certain scalability. When you add 4 nodes, you have certain scalability numbers. You can see that this is actually going pretty linear. And don't take my word for it. This is actually a SAP certified SP benchmark results. So what is this context about this with the cloud, where you have typically 2-node environments? The point that I'm trying to make is, even in the cloud today, we don't have a set way of starting to choose a node. What I mean by that is, okay, so let's say you go to the cloud, you sign up, you say, okay, I want to use the cloud services. It gives you a choice. Well, how many OCPUs do you want? How much memory you want? And yes, there are ways to increase the number of OCPUs, but after a while, that also gets stuck. Now with RAC, what you can do is start with something small, okay? And you can increase by adding more nodes. So how is this beneficial? Well, there are two things that I can think about. One is the fact that if you know recently what happened, the issues with Spectre and the issues with all these other security issues, which require that everybody just take a hard stop and apply these patches because they're really, really bad, right? Because there's bad security issues. Now, in the case of RAC, especially if you use 2 VMs and we make sure they're across different hardware, which means you can actually take a planned outage to apply this fix. This is so cool because now you get the benefit of starting with a smaller footprint and get the benefit of availability. So this is really, really the way that you want to plan your, your cloud usage, especially with RAC. You have this benefit of availability and scalability. With RAC, and especially the ways that we have been providing RAC in the cloud, there are roughly 3 ways that I call it. OCIC, or Oracle, the classic infrastructure, and OCI, that is the newer one. And then the third one is Exadata, right? So you have all these choices that you can use. You can use to install RAC, set up RAC, use RAC. We give you all these choices. The only thing that a lot of customers ask me is about, hey, Neil, how do we get RAC on other providers? And there are technical reasons that I don't want to get in the context of these, but we can talk about it. If you have any questions on that, feel free to reach out to me on that. Okay, there's a bit more questions on the chat. So one is, I have a question for scan IPs. Are there a recommended time to live, time to configure? Interesting question. So what is TTL? Well, it's a setup at the network level, the time to live that we call it. With scan, all we ask that is to make sure that you set up a DNS entry such that you can only, have anytime you access that resource or host name or whatever, domain name, hostname.domain name that we call it, it has to be resolved to 3 nodes. What would happen internally behind the scene is we would create those resources as part of our clusterware. And then there are other things that would create, for example, scan listeners, then you create your services. Between all of these things, you do not have to specifically worry about the time to live, but you might want to look at, if you have an application that is getting affected because of this TTL is not set, you might want to look at, there are newer things like app continuity and all that to ensure that your application itself do not get affected by any kind of issues, whether planned or unplanned, when nodes join and leave the cluster, regardless of its planned or unplanned. TTL by itself is only a minor aspect of it. If there is an issue, we might have to take it offline and figure out what's going on. But just to answer your question, you do not have to worry about time to live settings, specifically in the context of scan, when you're configuring your RAC cluster. Now, hopefully that answers your question. I want to talk, and I don't see any more chat questions. Just make sure I have any. No, there's none. Okay. Good. So now I want to touch a bit about a couple of things that have, these questions have come to me from the tweets that I posted. So I'll talk about a couple of those questions that are coming up. Okay. So start sharing, that way you can see it. What are the questions? Okay, share screen. The aspect of seamless integration without application code changes is something that I cannot highlight enough. For example, it's not that you use RAC on its own by itself. You can seamlessly integrate it with DataGuard, and there is a 12.2 feature that we can talk about. You can seamlessly integrate it with multi-tenant. You can integrate it in memory. We talked a bit about that. And there are more things we can, obviously it is well integrated with Exadata. These are the things that, the question that was is, so should I use DataGuard or RAC? Well, there is really no such thing called or. The MAA team publishes a blueprint that you can access by going to www.oracle.com slash go to slash MAA, which kind of tells you how do you plan these things. For example, if you want to ensure that your database is available, you want to make sure that you use RAC. If you want disaster recovery, you set up this data guard so that if in case of a site failure, you can seamlessly fail over. You could use PDBs, and there are a lot of features with multi-tenant or pluggable database that is out of the box, figured for you with multi-tenant, and the same with in-memory. Obviously, using in-memory with what we call engineered systems like the Oracle Database Appliance and the Oracle Exadata gives you the best of everything. There is another aspect of this. In the past, RAC used to be just the database specific option. Today, I call it that RAC is now actually, it's better to call it RAC family of solutions. What does that mean? So what does a family of solutions mean is RAC is the aspect or the entity which works in the database area. There are other products like, for example, ASM, which makes it so much easier to have your shared disks. You don't have to provision stuff and move stuff around. You just tell ASM, here's a bunch of disks, and we will take care of it. With filter driver, we even make it much more easy. Right? There are other aspects of it. For example, let's go back to we can see the autonomous health framework. It's a new initiative. What is an autonomous health framework? We'll talk about it a little bit. There is also Oracle Clusterware. In the past, we used to rely on external entities, like you need a vendor clusterware, and sometimes this vendor clusterware, even though it is designed with the best in mind, there is a bit of an interaction issue. Its view of a node is, hey, it's good, it's up, but in the database context, it may not be. So we had to design our own clusterware so that it's an integrated solution for you to get the best of availability and scalability. Same with ACFS for storing your external files. There are a lot of features in ACFS. For example, you can do tagging. You can actually replicate your files. This helps a lot because not everything is stored in the database. Obviously, you can, but there is a choice we give you. Then there is something called as RAC1 node. I'm sure everybody knows what RAC1 node is. And if not, remember those old failover solutions that external vendors used to offer? Well, RAC1 node is actually one step ahead, and it's a kind of a little bit enhanced solution than that because what we call is we make sure that the cache is filled before we take down the node for planned downtime. What does that mean? It means that in the past, when you look at the other solutions by other vendors, the database is moved to another node, and then the cache is empty. So all the queries may get affected by the performance of all these physical reads and physical writes. This feature makes sure that when you move something, we move it without any effort, in the sense that the effect is mitigated for customers because we try to ensure that the cache is warm, or we pre-warm the cache so that when the session moves over, it does not even know that actually the other node is down. And essentially, that's what customers want. They do not want their sessions to know about this, that something happened, or that node is down. I want to take a minute to also explain this, this thing. So I'll just take a minute to show this. This is very okay. Sorry about that. It's slow. I think the refresh is taking a bit more time. So I will get into this. Sorry. Now I have to share. Okay. So there was a question on the specific feature of PDBs and how RAC can help. So let me get to that. So in the past, before 12C release 2, there used to be this concept. And again, this is a four-node cluster. And you can see there are various PDBs. Now, if the color is the same, that's meant to depict that in this case, this PDB is running on node 3 and 4 of the cluster. So this is node 1, node 2, node 3, node 4. And they are spread across. Obviously, in a consolidated environment, you definitely want to use a rack so that you ensure that your one host down or one HPA down does not take down everything. The only thing that is an issue in the previous releases, that is in 12.102 and old releases, is that we used to send this inter-cluster messages, the cache fusion messages, all over the place. So what I mean is, this messages, the rack could not, raw rack could not, figure out that these messages are intended for just these two guys. So it will send it to everybody. Now in 12.2, what we have done is we have actually made sure that these guys are only sent to the nodes where the instances of that PDB is running. For example, if this PDB wants to send a message about this PDB only, why should we send it to everywhere else? So we have now this feature by which we, regardless of the number of PDBs, we only send those messages which are from one PDB to other PDB only to each other. Okay. The benefit of this is obviously if this node goes down, these guys are not worried because hey, I don't have to worry as long as my buddy or my other instance is going to be running on the other node. Be good. So this is a very interesting feature that is new in 12C release 2. This helps a lot in ensuring that we do not inundate everybody, all the nodes of the cluster by sending messages left and right. We are optimizing these messages so that only the PDBs that require these messages get those messages. Obviously, in a cloud environment or whatever other environment, this is obviously more secure because you're not sending the message. If you're not sending the message that is not intended, well, the security out of the box for you. But I'm not more worried about in this context the security. I'm more about the amount of messages, because regardless of how much you optimize these things are taking memory bandwidth and bandwidth on the private interconnect. So this is actually a very cool feature, and we have tested that this feature along with our recovery buddy ensures that things are really, really optimized and fast in a PDB environment. There is another aspect of this that I want to talk about, and I'll just get into the hang manager, especially since this question is about PDBs. I don't think we talk much about the hang manager. It's a very internal feature. We don't talk much about it. However, it's very important that this information is, the customers are aware of this. Essentially, a hang manager is a process which will figure out automatically, without you saying anything, if something is stuck and preventing others from proceeding. And I like to give this very simple case where somebody does a lot of inserts and does not commit and goes away, and then the other guys are waiting forever. In the past, again, it's a very simplified hang that I chose, but there could be other things. For example, somebody's trying to write a control file, a backup is going on, everybody is stuck. There are a lot of these things that are going on, which will cause loss of availability in the database. In the past, I know many of you work with support. We take a system state dump. System state dump is nothing but a hang debugging mechanism. And then we will say, oh, node 2, process 15 looks like it's hung. Can you please look at it? And you would say, give us some details. We'll go back and forth. Eventually, you'll make a decision to do something about it. Hang Manager kind of does this automatically for you. So it kind of detects. If it detects a hang, it will evaluate. Now, in the detect phase, there are two things we ensure. We make sure that we are only doing or managing those sessions that are waiting on another resource. Okay. So in this case, you can see here, this detect phase, we are in this time waiting on a timer. The timer, we will figure out if the guy who's holding does not move. So if we take a dump and it's still, the system state dump is still showing that, oh, this guy's not moving, we will know. Again, we do this internally. We actually don't rely on doing an actual system state dump. We actually have this information internal. We can access this information. So we don't actually have to dump it out to a trace file. We have it in memory, so which makes it kind of better. We keep analyzing until we find out and confirm that it's a hang, then we take action. What that action could be is we could kill that or terminate that process. Now, obviously, we won't terminate backup process. We won't terminate critical background processes, but we would terminate certain things which we believe could affect it. Now, this can transform between, or this actually is smart enough that if there is a issue on the ASM instance and the hang is on the ASM side, we would actually be able to call out to the hang manager running on the ASM side and do something, take action. So there are a lot of these things that are going on that we try to optimize for you. Okay. So I hope that answers some of the questions about the integration of multi-tenant with RAC. So I'm just going to go and check in the chat screen about any more questions. Yes, and there's another question I can see, and that is how RAC decides which is the node less loaded to connect new session. Oh, good question. So this is, I don't have a slide deck for it per se, so I will talk a little bit about it theoretically. We have what we call as runtime load balancing, and we have connection load balancing. Obviously, if you have listened to any real world performance seminars, RWP we call it, these are the sessions that are provided by our internal performance tuning guys, which is available for customers. One of the things they highlight is do not rely on session login stalls. What does that mean? It means that do not ever have an application that kind of goes and connects like hundreds and thousands of sessions at the same time. That is a really bad design because, again, it's nothing to do with Oracle or RAC in this context, but anytime you need to connect, the operating system needs to spawn a new process, and that is very time consuming. And if it has to do a bunch of it, it kind of slows it down. So before I just answer about how does RAC decide, let's make sure that we understand and we explain that you always want to go through some application server which has some kind of caching scheme. It'll pre-connect something and all that and all that. At the Oracle side, you could say that when sessions come in, you can decide or define whether you want to do connection balancing, which means we randomly put those connections on different nodes. So let's say you have a 3-node cluster and your service is running on all the 3 nodes. We would put them on node 1, node 3, node 2, and we kind of spread it across. We have a way to figure out if node 2 has more memory and more CPU. We kind of figure that out and do not rely on customers. And that's where our session, runtime load balancing comes into effect. Obviously, sometimes we would have this big job running on certain nodes, and you don't want to connect that node. Well, then you want to set up runtime load balancing. In runtime load balancing, we will actually figure out that the node is busy, and you would say, you know what, maybe you should send it to the other guy. So there's ways to spread the load So that's how Oracle decides which is the node less loaded to connect new sessions. Okay. Now there is another aspect of this, and I'll just jump over to that because there is another aspect to this, because somebody asked me in the Twitter when I tweeted about it, how does Oracle actually evict a node? I'm going to spend a couple of minutes on that, but I think I'm coming up very close to the end of the hour. So I want to make sure that we cover everybody's question, and if not, we can always do it next, in the next one. So there you go. Okay. So the question is, how does Oracle evict a node or decide to evict a node? And luckily, I have some slides on this. So the eviction basics are very simple. In pre-12.2, we would always evict the lowest node number. So in this case, node number 1 on the left side, node number 2 on the right side. And if something happens, that is an animated way to show a split frame, then this guy will survive, this guy will crash. Okay, or be evicted. We kind of say do not rely on this functionality because it might change. And actually, in 12.2, this has changed a bit. In 12.2, node waiting is a feature introduced where we try to ensure the majority of the work survive. What does that mean is, now take this case, node 1 and node 2. Node 1 has no databases remaining, or it's not running any database. Node 2 has these two of these database or PDBs, however you want to call it. In the earlier method, we would automatically kill node 2 and node 1 will be there, but what's the point? There's no database there. In the Oracle 12c release 2, with this feature, what we have done is we have essentially changed the algorithm by which we let majority survive, or majority of the work survive. This means that since it's a 2-node cluster and node 1 was not running anything, we will evict node 1 and we'll let node 2 be in and continue work. Now, when I want to ensure what we call equal, so it's not just a 2-node cluster, it's a 3-node cluster also, you could have a split brain. So we try to ensure these subclusters that are formed is good enough in the sense of how or who survives. The majority of work running on that instance need to survive. We also take care of additional failures. For example, let's say we have a public network failure on node 1. We kind of take care of that in the sense that what's the point? In this case, you have 2 nodes. You have a database running on each side. So you could take out anyone. But we figured out, hey, you know what? There's no point taking this guy out because there's a public node network failure here. A public network failure means external clients cannot connect. So we kind of try to figure these things out and ensure that we keep the guy available who's can do work. If there's a conflict, we also rely back on the we kind of fail back on the old algorithm. That way we don't know what to do. For example, in this case, you have this case where node 2 is not running any database and node 1 is having a database and a public network failure. Well, regardless of whatever we do, there is some issue, so we kind of fail back. Okay. There is a way for customers to identify these and mark certain things. So you could define something what we say CSS critical, which means you can identify a node or a component and say, hey, mark this guy as critical. And we would try to take that into account while we are evicting a node. Now, again, this is completely optional. In fact, I would recommend, unless you are really, really, really sure what you're doing, to not get into this thing. Right? So that's one thing I would recommend. You would set it using this command called crctl set server at the server level. You could also optionally set it as a database level, like you could say CSS servctl modify database, and then you could say CSS critical. So this is the case where you have consolidated a lot of environments, and you want to make sure that you are actually ensuring that you do not You want to keep your database service all the time available. So this could be a consolidation environment where you have 5 databases, but your most critical database is database 1 or PDB 1 or whatever. Okay. So this is very important. Again, this is optional. I don't think you need to set it. You could do it though. We will try to honor CSS critical. So let's say you define it this way, where you have one database of PDB on this left-hand node 1, which is called Venus, and on the right-hand side, you have 3 of these guys. Now, by typical mechanism, we would have kept 2. But since you said, hey, Oracle, I know what I'm doing. I want CSS critical defined here, so I've defined it here. In this case, we will evict the other guy and keep this guy. We're kind of honoring your request, right? The problem is, we let you could define certain database and certain node as critical. Really, really bad idea. Don't do that. But if you do it, it will end up into this conflict mechanism. In the sense that we would not know what to do because you defined 2 nodes and you said all are important. So we will again go back or rely on the pre-12 behavior. Okay. Now, that pretty much is all I wanted to talk about in that sense. So let's see if there's any more questions. Okay, I don't think there are any more questions now, and I think they're very, very close to the hour. So I want to ask a couple of questions for you. Is this a good time? First of all, let me know. We can always work around timings. There is not a good time for everybody because I try to make sure Pacific time zone, East Coast time zone, Europe, they all can be, I'm sorry about Asia, but I'll do another session then.
This works.
Perfect. Perfect. Thanks. And like I said, we're going to have this as a series of sessions. So if you have any questions that you want to talk about, you can send it to me up front. I have shared my initial contact information. You could tweet, actually, directly tweet, so that other folks can look at the interest and let us know and maybe join or give us some more feedback about how that feature or aspect, what was their feedback on that. But definitely do send it to me what you want, what session you want to cover. Like I said, RAC family of products is a huge area. You have ASM, you have clusterware, you have failover, you have node eviction basics. You have so many things that we can talk about. I actually also want to do a session on how do you figure out, or if your hang manager has killed or terminated a session, so that you are aware, so you know what happened, and you are able to define and defend yourself. Because typically, I guess a user would come to you and say, "Hey, this thing got terminated." Well, then you know why, and maybe you can tell him and work with him on how to improve and fix your application. Okay. So with that, I will wait for a couple of seconds because I've got 2 or 3 minutes left, and then I will stop this session with the expectation that if there's anything more, we will cover it in the future sessions. Again, very sorry about this sound quality. I thought I had it all covered up. We tested it, Stephen and I, but looks like it's coming and going. So sorry about that. So I don't see any more questions. So again, thanks again, all of you, for attending, and have a good rest of the day wherever you are. And again, please make sure to attend the next session. And again, feel free to send me the questions up front so I can ensure I'm catering it to your questions. Thank you.
Thank you.